So now we're going to look at an example of functions where we're actually going to look at the parameter specifically, and we're going to do what's called CallByValue versus CallByReference parameters. So the first thing we're going to do here is we're going to declare our function. We're going to declare a CallByReference function. Or sorry, let's do a CallByValue first. And this function is going to return a value. It's going to be, I'm going to do a function that's going to square a value. Now we already saw that there is actually, remember the power function in the math library? We could do squaring of a number, right, with a power function. But we're going to create our own. So just to show you. So that's going to be the declaration, and the definition of this I'm going to go, I'll do int value squared and what I'm going to do here is I'm going to just say a equals a times a. Now there's other ways we can write this obviously, but that's what I'm going to put here for now. And then I'm going to return that value. Make sense? And I'm going to create some number, let's do 8. And what I'm going to do is I'm going to first do this CallByValue. So for the CallByValue, what I'm going to do here is now I could just do here, if I wanted to, I can do, so let's say sum. Or square. Let's call it square num. I'm just going to set it to be 0 to start. I'm going to make square num equal to what? The value squared. And I'm going to pass in num. Does that make sense? So what I'm saying here is I'm going to take in that integer num, which is the 8, as a parameter, as a CallByValue parameter, and I'm going to then take that in as 8. So the 8 will be passed in as the parameter. So our int a here, a will equal 8, and then I'm going to make a equal to 8 times 8, which is 64, and it's going to return 64, which is the square of 8, right? Okay, and then what I want to do is I'm going to actually display this out. The square of and just so it doesn't get too long, I'm just going to make it over 2 lines. So I'm going to say the square of the num is square num. Any questions here? Yes?
How do you know that it's going to get passed to a?
Okay, so what we're saying here is num here, we have an integer num in memory, right? So that has the value 8 stored in the memory location, which is the variable num. You with me? What we say right here, for value squared, what we're saying is pass that num value in as a parameter. So pass in the value of num as a parameter. What's the value of num? 8. So when we go down here and look at the definition, the parameter is given the name a. So what we're saying is pass in num's value and save it as a. Okay? So our a here will now be 8. So there's now a new memory location with 8 in it that is for variable a. And then we just use it the same way as if we had declared our integer a in the main like we've seen before. Does that make sense? Okay. So what I'd like to do is show you is we have this as our CallByValue example. So let's see how this works. And this is example 2. Don't forget, if you're doing the compilation and using the up arrow key to select, that it's example 2 we're compiling now, not example 1. So let's compile it. It does compile. So now I'm going to run it. And what does it say? Call by value example. The square of 8 is 64. Sounds good, right? Right? So it turns out the example I showed you before with hello also was using call by value. And in call by value, the parameter here, what you do is you pass in the value of that variable. So if the value of the variable num is 8, you pass in 8 as the parameter. Does that make sense? We're good? Okay. Now, what about call by reference? So for a call by reference, the real difference here is I'm going to call it ref squared. And instead of taking in an int, we're going to take in a reference to an int. So it turns out, you might say, wait a sec, I thought you couldn't have two functions with the same parameter. Right? Same name, same parameter. Well, this is a type int. And this int ampersand here is really saying an address of int. Okay? So this is a different parameter type. Int ampersand is not the same type as int. Okay? I can use the same name here, but I could use b here. It doesn't really matter. Would you prefer I use b to keep it simple? Doesn't matter. Yes?
When you do call by reference, shouldn't you use star instead of the
No.
symbol?
No.
So you're going to pass the address?
I'm going to pass the address. We're going to learn later when we do pointers, which is a topic we'll do later. We're going to learn the difference between those two operators.
So you're going to pass the address then?
Right.
Okay.
So we're going to pass in the address. So basically, if you had that value squared down here, I'm just going to cut and paste it, and we're just going to change this call by reference function, and we're going to call it ref squared and int ampersand. Everything else is going to look the same. So what's the point of this? If it looks the same except for that one little change, which is, no, I did rename the function. Sorry, I should have said that. So the name of the function is different, but the difference here is that this one it passes it in as a call by reference versus call by value. Let's take a look now and see what the difference is. What? No, that's all fine. Hold on. I know you're getting ahead a little bit, but I want to get everybody there by understanding how this works, not by me telling them. So just give me 1 second. So for the call by reference example, I'm basically going to have the exact same code, right? And this is what I'm doing. Okay? So for the call by reference example, I'm using the same input. I'm going to copy its solution into the same variable, which is fine. And I'm going to display it out. What will the value, so this is what our call by value output was. And we'll see that again. What will the call by reference value be? It should say what? The square, what would you like it to say? The square of blank is blank. What will it say? No. How many of you would like to see it? Why don't I show you? So if we now compile it and run it, it says the square of 64 is 64. Wait a sec. What just happened? Yes? Right. So here's the thing that's a little bit of the head scratcher, the thing you have to get your head around. Remember, how did I explain call by value? With call by value, I said, right here, what you're doing is you take the value of the num variable, 8, right? and when you pass it in here as a value, it takes 8 and it copies it to a different location in memory and stores it there and has where that's what A refers to. So this variable A has a value of 8, but it's stored in a different memory location than num. When you do a call by reference, what you're saying is, don't pass me a copy of the parameter value. Pass me the reference. Pass me the location in memory for it. So now when we do a call by reference here, instead of when we pass it num, we don't take a copy of 8 and store it in a new location, which is the variable A. What we do is we take the address of num and we make A also refer to that same address. So now we have one memory location, which has the value 8 in it, and num and A both refer to it. And what that means is any changes, like we see here, that we make inside the function to A will also affect num, because they're both the same thing. Okay? Does that make sense? Not global variable. What you're really doing is you're making it accessible. So the original function accessible. Let me just show you the example here. Let's actually add in the memory locations. Do you think that would help? It does. And the reason you want to use call by reference is, although in an int it's not a big deal, but in certain cases, one of the main reasons you want to use these is that what about if you're dealing with a really large amount of data and you want to calculate something? You don't want to make a complete copy of something really big. Instead, what you want to do is you want to just say, hey, let's work with the original one. Okay? Now, there is something you can do here to protect against it being changed. And I'll show you that later. You can actually put the word const here. Okay? And if you put the word const, what does const mean? It means a constant. So if we put the word const here, what you're saying is pass this by reference, but ensure that the function doesn't change the original value. Okay? That's what this means. So if we actually now compile, if we now compile this again, it's going to give us an error because it told us, because we made this a constant, we said it was read-only. And what did we do here? We tried to change it. So it gives us an error and says, hey, you have a read-only variable and you tried to assign to it. So if we wanted to do this as call by reference, we could do this instead. Right? We could do that, or we could simply just create a new int b and then do this. Right? And now if we compile that, it'll work fine and it's constant. Okay? I'm going to save that as one example. I'm going to save that as example 2b, just because I want to put both versions up. But so let's get rid of the constant, though. I want to go back to the way it was. Just give me 1 second here. Let me just change this back. So now we're back to the way it was. What's your question?
So let's say if we pass a structure through and it's const, so it doesn't allow you to reassign the variable, but you could still change the value within it, right? Like you can't reassign the actual variable, but you can still.
So I know what you mean, and we're not there yet in the course. So just hold that thought, and we will get there. Though it is something that's true. What you're talking about. I know exactly where you're going, but we'll hold off for a second. So just so that everybody understands, what I want to do is I want to just show you something here. So we're going to show out memory addresses here now. So the memory address of num. Okay. Now we can actually display the memory address of any variable by putting that ampersand in front of the variable name. It's called the address of operator. So if we do this, let's just do this first, just so we can show you here. Oh, thank you for noticing when I changed it. Okay. So if we actually compile this now and run it, oh yeah, did I change the name of this to 2b? Yes. Okay. So what does it tell me here? It says memory address of the num is, and it gives me a big number in what's called hexadecimal. Do you guys remember what hexadecimal is? Have you ever heard of that?
Base 16.
It's base 16. So first off, this is just a memory address. You don't need to understand how to read this. All you need to do is see, I want you to notice if one address is different from another. But this really is a number, but the difference is it's a base 16. So when you deal with decimal, the normal values we deal with the base 10, right? Where we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the different digits we can have in a number. When we deal with when you deal with binary, it's base 2. You only have 2 digits, 0 or 1. When you deal with hexadecimal, it's base 16. So you have the digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But instead of going to 10 using 2 digits, you then also have A, B, C, D, E, and F. So you can get these numbers that include A, B, C, D, E, and F. And these are really just the 6 extra digits that you can have. So don't worry about this, but that's our address. Now what I want to show you is in our value squared, let's print out the same thing. We'll go cout, and we'll go memory address of A is, and we'll do ampersand A right here. So let's try this now. So when we run this and compile it, what do you notice about the address of A in the call by value versus num? Is this the same as this? It's not, right? And that makes sense because I told you what happens is A is a different variable, and what you do is you take num, you take its value, and store it in a new variable, a copy. Right? So A points to one memory location, which has 8. Num points to a different memory location, which has 8. Now, let's take that same statement and copy and paste it down here. In our ref squared example, if we compile and run this again, what do we notice? The address of num is here. The address of A when we do call by reference is here. And the address of A when we do, call by value is here. And the address of A when we do call by reference is here. And when we do call by reference, what do you notice about the memory location of A? Yeah. It's the same as num. So what we've done here is we've passed a reference. We've passed the address of num and said, hey, make A variable use the same location as num. So rather than making a copy of that integer 8, storing it separately, we've just made A and num refer to the same memory location. And that's why when we do something like this, we get a value for A gets changed to 64. Does that make sense? Okay, so that's a first introduction to call by reference and call by value and what the difference is.